Have you ever found yourself tangled in the complexities of threading in a JNI environment? It can be quite a challenge, right? If you're struggling with synchronizing threads between C++ and Java, you're in the right place. Today, we're going to unravel this tricky topic together. I totally get it. Synchronizing threads can feel like trying to solve a puzzle with missing pieces. You're not alone in this. Many developers face similar issues when trying to manage data access between C++ and Java threads. Here's the specific situation we're addressing. One user asked, how do I properly synchronize threads on the native side of a JNI environment? They mentioned that both a C++ thread and a Java thread are accessing the same data, and they want to ensure safe access. Sound familiar? Let's dive into this together. So, what makes this synchronization tricky? The challenge lies in the fact that while Java has robust concurrency features, C++ requires a different approach. We'll break down the options available to you and help you find the best solution. And stick around. At the end of this video, I'll share a powerful tip that could simplify your threading issues significantly. To properly synchronize access between the C++ and Java threads, the user should utilize JNI's built-in monitor functions. These functions are monitor enter and monitor exit, which handle locking on the C++ side. Next, the user should ensure that both the C++ polling function and the Java data supply function are wrapped in these monitor calls. This will prevent race conditions when accessing shared data. Additionally, the user should be aware of potential pitfalls when mixing JNI monitor functions with other synchronization methods, such as p-threads. It's crucial to avoid deadlocks by not locking the same resource with different methods. Finally, the user should test the implementation thoroughly. This includes checking for any potential deadlocks or race conditions during the interaction between the C++ and Java threads. Fun fact: did you know that the concept of threading dates back to the early days of computing? It's fascinating how far we've come, yet some challenges remain the same. Now, let's look at the answers provided by other users. An alternative approach to synchronize threads in a JNI environment is to use JNI's built-in synchronization functions. Specifically, you can utilize monitor enter and monitor exit to manage locks on Java objects. This method allows both C++ and Java threads to safely access shared data. It's important to note that mixing JNI's monitor functions with other locking mechanisms can lead to issues. Always ensure that a monitor entered with monitor enter is exited with monitor exit to avoid deadlocks. That's it for that response. Let's explore another one. An alternative approach for synchronizing threads in a JNI environment involves using both a native mutex and a Java monitor. The user suggests utilizing std mutex for synchronization within native threads, along with std lock guard for easier management. They recommend creating a wrapper for the Java monitor to integrate it with std lock guard, ensuring better synchronization and reducing race conditions. Here's the tip I promised: always document your threading logic. This will not only help you, but also anyone else who might work on your code in the future. And there you have it. With these strategies, you should be able to synchronize your threads effectively. Remember, proper synchronization is key to avoiding data corruption. If you found this video helpful, please subscribe for more tips and tricks.